The Namib Desert in southwestern Africa. Here there are dry periods lasting decades, temperatures higher than 50 degrees Celsius, and few signs of human habitation.
There's possibility to put up these solar plants for the good light, open spaces that we have, the sun that we have, it's all here available.
The Namib stretches along the west coast of Africa for more than 2,000 kilometers. The region gets 3 times as much energy from the sun as Central Europe and has lots and lots of space in a fascinating desert landscape. But it not only offers optimal conditions for producing electrical power from the sun. A cold ocean current from the Antarctic meets the coast here. The extreme temperature difference between the sea and the land produces a constant wind that blows far inland. In the Socio-Economic National Park in southern Namibia, Susan Jaleka is surveying a potential site for a wind park. Here in Namibia's so-called Sperrgebiet, or restricted area, diamonds were mined for a century.
What is planned here is the green hydrogen plants, which is also especially going to be the ammonias, and then the wind farms. So ensuring that we in one of the countries in sub-Saharan Africa is leading to address issues of climate change.
The diamond deposits have been largely exhausted. For the future, the plan is to exploit the renewable resources here. The conditions seem perfect. Experts say the area is a global hotspot for renewable energies. Both solar and wind energy are at least 3 times more intense than in Germany. An international consortium is planning to build huge wind and solar parks with a total capacity of around 5 gigawatt. Desalination plants are to turn the salt water of the nearby Atlantic into fresh water. The desalinated water will flow through pipelines to electrolysis facilities. These will use the climate-neutral electricity and the water to produce what is called green hydrogen. The carbon-free energy carrier will then flow via pipelines to a harbor. There, a special factory will use the green hydrogen to synthesize another energy-dense substance. By combining nitrogen from the air with the hydrogen, it will produce a form of ammonia which can be loaded onto ships for transport. This climate-neutral energy carrier, dubbed green ammonia, can then be distributed to markets around the world. Namibia today is beset by many problems. Most of the people around the country's big cities live in slums. Over half of the population has no reliable electricity supplies. More than half of young people are jobless. The port of Walvis Bay is home to Namibia's largest industrial zone. But there are few solar arrays to be seen on the factory roofs, despite the huge availability of solar energy. Namibia imports 65% of its electricity from South Africa, most of it produced from coal. Detlof van Oertzen is a Namibian energy expert.
If
we want to develop Namibia in a sustainable way in the long term, then we have to ensure that these projects underway here really fit into the socio-economic framework of the country. If we allow these processes or projects to take place in enclaves, that will decouple them from Namibia's development, and that would be catastrophic. Some 10,000 kilometers to the north, the Fraunhofer IEE in Kassel. Here, young scientists are assessing more than 600 sites around the world in terms of their potential for producing climate-neutral energy carriers, such as green hydrogen. The researchers examine not only the available solar and wind energy, but also socioeconomic factors, like the distance of sites from cities with potential workers, or environmental protection regulations, or the political situation in the region. Their study shows that even in future, Germany will only be able to import limited supplies of green hydrogen. The amounts that can be imported would only serve to supply air and maritime traffic, or the energy-intensive steel industry, or the chemical industry. One industrial site that will require large amounts of green hydrogen in the coming years is ThyssenKrupp in Duisburg, in western Germany. Here, steel is made from the raw materials bituminous coal and iron ore. Coke and ore are heated in huge blast furnaces to produce the so-called pig iron that will be further processed to make steel. Coal powder is injected via special lances into the furnace. Then the coke and the iron ore are heated to as high as 2,000 degrees Celsius. The problem with this method is that it emits huge amounts of climate-harming carbon dioxide. CO2 emissions from the steel production in Duisburg is 5 times higher than the total from all German domestic air flights. To make steel production climate neutral, a completely new type of blast furnace is being planned here. In the future, the iron ore will be processed without coal, which is to be replaced by green hydrogen. This new process would emit no CO2, but just steam. A number of further steps would yield climate-neutral pig iron. In this innovative method, every ton of green hydrogen would eliminate 26 tons of CO2 emissions. This is a more efficient use of green hydrogen than employing it as fuel in transport and heating, for instance, as a replacement for gasoline or diesel and natural gas. In this industry, it will give us a much bigger leverage effect. By using hydrogen, we will have a larger CO2 reduction than, for example, in heating or in other industries. Germany's steel production is responsible for around 5% of the country's greenhouse gas emissions. So it would make sense to utilize the expected limited supplies of green hydrogen in this industry. The researchers at the Fraunhofer Institute have analyzed not only the potentially available amounts of green hydrogen worldwide, but also the costs. Our analysis shows that using green hydrogen in automobile traffic or in the heating sector makes no sense. The costs there are considerably higher than for fossil fuels, 3 or 4 times as much. So we should advocate electric cars or heat pumps for that kind of mass usage. The results from the Fraunhofer study are unambiguous. Climate-neutral energy carriers from Namibia or other countries with high renewable energy potential will not be in great supply. Therefore, they should be deployed efficiently. Namibian companies and German engineers are also eyeing another resource that the country has to offer: This is iron ore, an important raw material from Namibia. Our plan is to make pig iron from it. We have the raw materials, which up to now have been exported in the raw state without added value. And using renewable energies, we can make a product here in Namibia with Namibian workers and promote Namibian training. That is a real revolution that is great for Namibia. The idea is to use the green hydrogen locally, not to export the iron as ore, but to produce pig iron in smaller, innovative furnaces close to the mine. That means a large part of the value added would be realized in Namibia. That would create jobs and, ultimately, more prosperity in the country. The international consortium that is planning the big renewable energy and electrolysis facilities for green hydrogen in the south of the country says that it will create several thousand jobs in the area even after the construction phase. Robert Hoppaditzel has been building solar plants in Namibia for more than a decade. Now the country's largest photovoltaic power plant has gone up near the central city of Omaruru. When these kinds of factories start up, they will also carry out training. Like in Germany, there will be apprentices. They may be called something different here, but in this way it will self-perpetuate. They will train their own young people. I think you can guess from what I'm saying is that I'm absolutely euphoric about this. Whether a renewable energy boom in Namibia will really benefit all the people here will depend on how willing foreign investors are to train local workers. Only that can promote a development that will remain once the green energy carriers have left the country. For Germany, it is not a sustainable strategy to assume that countries with abundant renewable energy will make its own transition to renewables superfluous.
It's not a good idea. It's our resources. We need to make use of our resources and industrialize our countries. We want to build our own industries within Namibia, part of Africa, to develop the African continent.
The potential for renewable energy in Africa is enormous. If this potential is used wisely, it offers a huge chance, both for developed industrial nations and for the African continent.